Good morning. Today I'm going to be presenting information on increasing health hazards, those associated with climate change. I'm also going to be presenting information on some causes of climate change and presenting a couple of ideas and a couple of resources that might be available, especially here in Alaska, to reduce our consumption of power based on fossil fuels and those that don't require nuclear. My name is Paul Vaona, and I want to thank you for taking the time to review this information. There are many different health hazards that are increasing over time that can be associated somehow with climate change. For this talk, I'm going to limit myself to just two. The first of which will be vector-borne, and that, of course, will be consideration of the mosquito, or as we here in Alaska refer to it, the Alaska state bird. The mosquito quite possibly is responsible for more deaths in the world than all of the wars combined. Currently in Africa, the death toll is about 750,000 die each year of malaria. That's not including any other diseases, and that is also despite aggressive control methods. Next, we'll look at Historiobacterium and viruses, in this case specifically the bacterium of anthrax. This is almost always a livestock-borne disease. It is in both domesticated and non-domesticated animals. It's rare to find this in humans. There have been, of course, cases where governments and militaries have weaponized it to make it more bioavailable for humans. But the naturally occurring anthrax is actually quite rare in humans. Untreated, it does have a mortality rate of about 20 to 80%. And it is found truly throughout the world. There doesn't seem to be any environment where it is not found in livestock. So, looking at the mosquito, the paper I read, which I found very interesting by Paul Ryder, and I hope I'm pronouncing that correctly. What Mr. Ryder talks about in his paper is he's looking at how climate change and warming trends have affected mosquito populations. But he's also not going into the specifics of whether or not climate change is man-made. His work doesn't have a lot of controversy. It is agreeable. You find it difficult to point to any data that he has and not find it very likely. He does bring up that climate change and these warming trends have been going on for near 300 years. Again, not discussing the wheres, the whys, and the whos at this point. We do talk about the fact that as far as mosquitoes go, they are a prolific vector for many diseases. We've got malaria, yellow and dengue fever, West Nile, Zika. There's just a whole myriad of diseases that mosquitoes are vectors for, and they are found in many areas throughout the world. We think of malaria as an African and tropical disease, which it is, but there have been West Niles in New York. There have been West Niles in Sweden. So whereas we think of the big malaria associated with mosquitoes, they are vectors for many diseases. As the global temperatures do warm, again, no one's arguing that climate change is happening. There is evidence to show this may increase the range for the mosquitoes with these warming trends. They Some species winter over very well. Um, the warming, more standing water, shorter, less harsh winters provide an environment that the mosquitoes can winter over, even in Alaska, even some of the coldest areas in Alaska, we still have mosquitoes. Um, what Mr. Ryder discusses is this going to produce greater outbreaks? Are we going to see more frequent and larger outbreaks of things like malaria, West Nile virus? And his argument is not necessarily. His research shows that there's a lot of factors that lead to both more frequent and larger outbreaks and less. And probably the most significant is human activity. Whereas we may deforest a large area, we may have larger standing water. On the opposite, we may be using more chemicals to control. So there may, with the warming temperatures, we may see an increase in mosquito population, at least temporarily, but humans can control that. And areas that humans have gone and deforested could quite possibly lead to an increase in population, not necessarily because of global warming. So again, human involvement does play a key role in these outbreaks, and we shouldn't exclude that from um, our plans and our research of how to control what is going on now and what potentially could be going on in the future. So next we're going to talk about anthrax. Um, I think after 9/11, there was fear. Everybody was afraid of anthrax outbreaks. There was people that had um, powdered sugar from donuts on their legs that were being decontaminated by full hazmat squads. Um, here's here's a little thing. It's brown powder. It's actually tan powder, not pure white. So this is how we knew it really was an anthrax. But we went through the process. But this is weaponized anthrax. In the paper done, and I'm not going to pronounce their names because I will abuse it horribly. But the paper of thawing in permafrost may um, disrupt historical cattle burial grounds in eastern Siberia. In this paper, the authors look at the effect of rising global temperatures um, on the permafrost, which again we here in Alaska are very familiar with. Permafrost can range from just barely under the surface to several feet down. It is a constant in dealing with construction here in Alaska. Um, but what they're looking at in Siberia, and I've read some other outbreaks in Kazakhstan and even some of the Netherlands area, is that as the permafrost starts to melt, as it starts to get lower, areas where there have been burials of humans and of animals that were diseased. It may be an intentional burial. It may be where the animal has been afflicted with anthrax and has died, and over time has been uncovered or covered up, I should say. Um, the These areas, which were once frozen over, are now becoming exposed, now becoming unfrozen to the point where soil erosion may expose the carcass and may expose bacterium that is um, uh, live, that can be transmitted to another animal walking along the same area. What the authors were looking at is the effect in eastern Siberia, large areas where cattle have been fallen, where cattle have died, and they're concerned for how this is going to affect the livestock there now and the wild animals there now. This paper was actually interesting to read from a historical standpoint for personally. Again, not a lot of controversy, not a lot of this is anthropogenic. Really looking at this is the issue. We have global warming, which, people denying global warming, I rank right up there with, the flat earthers. We know that the global environment is changing. The controversy, of course, becomes the root cause of that. But this doesn't address this. This is looking at we have permafrost. It's starting to melt because of climate change. It's starting to bring up these bacterium, and could it have an effect, and what effect is it going to have? The other issue that they discuss is the possibility that as winters become more mild, shorter winters, this may allow for anthrax, and you can postulate that out with other diseases, maybe that normally would have died out over the winter because of the long frost. Now, with these milder temperatures and these shorter winters, could quite possibly survive and to continue on. So, the elephant in the middle of the room. Is climate change anthropogenic? That is climate change a direct result of human action and interactions in the world? This is controversial. Of course, we have the 97% scientists, the consensus, which, of course, if we listen to Aristotle, student of Plato, um, he equates the consensus argument, or as he called it, the herd argument, as one of the, I think it was the 12 or 13 great philosophical fallacies. Just because everybody says it's that way doesn't exactly mean it. There was a time when, yes, the consensus was the earth was flat. There was a consensus. There was a time when the consensus was, yes, the earth or the sun revolved around the earth. So we need to get past this consensus. We need to look at a couple of different things. Now, the rubric for this said to list 3 man-made, and I'm going to go out on a limb, and of course I may take a hit on point-wise, but I'm going to stand by my work on this. And what we're going to talk about here is water vapor. We're going to talk about solar activity. And of course, we are going to bring up fossil fuels. So let's talk about water vapor. Very unironically, Al Gore, in his work, An Inconvenient Truth, very ironically, he mentions that if we eliminate water vapor, 30% of greenhouse gases are as a result of carbon dioxide. Which, if you think about it, what he's basically saying is that the vast majority of greenhouse gases are not carbon dioxide, which is in fact the case. 70% of greenhouse gas, up to, there's slight variations, but it's a significant portion of greenhouse gas is made up of water vapor. We don't know much about water vapor. It's still an unknown. How does it affect temperatures? How does it affect the climate? It hasn't been a subject of a lot of research because, again, we've always gone back to everything is about carbon dioxide. What is interesting is that the water vapor question is actually, I would say, based on a lot of the reading, the #1 reason why all the climate models fail significantly. Even such that when they take every climate model that they've attempted to use, and they use historical data, That is, they took carbon dioxide levels and temperature levels in the past. They still cannot predict, knowing what the answer is, they still cannot predict the answer with their models. And the one thing is because of the water vapor. And when they've tried to add the water vapor element into it, again, they're just making guesses and they're still failing miserably. So I think when we look at the fact that water vapor is so little known, it is the most significant greenhouse gas. I think obviously this warrants a lot more research. Then we have to look at solar activity. Um, many ice core samples, including the Vostok ice core sample, which goes back over 400,000 years, there's a lot of data that suggests that CO2 may be lagging, that it falls behind the rise and fall of temperature. And I've heard people mention and papers mention this could be because that as temperatures do rise, yes, we have growth, we do have release of trapped CO2, but it's kind of the chicken versus the egg, what came first. And there's some data that suggests that CO2 is not a predictor of increasing temperatures or glaciation at that point. Um, what is found, and what I found very interesting in a lot of papers, and again, these are peer-reviewed papers, is that if we look at, especially like the Vostok ice core sample, which I've put the graph here, um, if we look at the past 400,000 years, there seems to be a closer tie to solar activity from the sun. Obviously, solar activity from the sun. Um, Whether or not CO2 has a play in it, again, there's a lot of data that needs to be gone through. But there's also suggestion that solar activity may play a key role in this, and it is something that we do need to look at. And of course, we do. We need to look at fossil fuels. I remember growing up in Los Angeles, and I remember going to school for over a month and not realizing I was bused to a school in the San Fernando Valley, and it was over a month before I could see the mountains surrounding the valley, and it's not a big valley. Of course, when we talk about fossil fuels, we're talking about carbon dioxide. This is the big one. This is the greenhouse gas that everybody's absolutely concerned about, the catastrophic damage. What is carbon dioxide? Well, first of all, it's a trace gas. Um, and by trace, I mean it represents 0.04%, even at the levels that they're saying now, that the 400 parts per million that we're at right now, it still represents less than a percent of the gas, 0.04%. Um, what it is, it's plant food. There's a lot of historical data that shows that there are times when the CO2 was much higher, and the dire prediction that we're all going to starve to death because of worldwide droughts is just not the case historically. And they have proof of this, and they have evidence that during times when CO2 was much higher, there was actually an overabundance of plants. There is a Nobel laureate um, uh, professor of physics that who believes that we are in a carbon dioxide drought. There's another physics professor who specializes in carbon dioxide with his work on lasers that has done a lot of research to show that plants today, many plants today, have actually evolved to live in an environment with lower CO2. And if the CO2 did increase, these plants would actually become more productive. And of course, the other one is if you look at most greenhouses, they actually pump carbon dioxide into the greenhouse to increase growth. But what does come from burning fossil fuels? And this is something that I would not fight anybody on. I don't think anybody with eyes would fight on either. Is that burning fossil fuels can be incredibly dirty. As I stated, I went to school in a valley, and it took me the longest time before I could see the mountains that were, less than 10, 20 miles away. This photo actually here is of Beijing. The CO2 level in this area is probably not that high, but we do see these products of incomplete combustion. We do see these volatile chemicals in the air. We do see these particulates. But what's happening is that we're spending so much time fighting the carbon dioxide, nobody's putting energy into cleaning up. It's a case of, well, we have to look at getting rid of carbon dioxide or fossil fuels because they burn carbon dioxide, as opposed to looking at, well, let's take the engines that we're using now and make them that much cleaner. There is clean coal with lower CO2 levels inside the coal. They put off low CO2, but the emissions are sent through scubbers to take out the particulates. And that's something I think that we need to address when we're looking at fossil fuels. As much as they would like to get rid of cars as soon as possible, I don't believe this is going to happen anytime. Certainly not, I don't believe in my lifetime. And I think a lot of effort should be cleaning up what we have and reducing. I truly believe we need to be good stewards of our environment. So, the fix. What can we do here in Alaska to fix the situation? Well, we can look at hydroelectric. And I'm not talking about large dams, and I'll get to that in a minute. Everybody hates large dams. They're projects of enormity. I suggest anybody interested look at the Three Gorges Dam in China, which took decades to complete, and the damage to the environment is horrific. So we're not talking about that. We'll look at biomass. And we will, wind and solar is something to consider. I'm not a fan of it. I think it's costly for the very little energy it provides, but it is something to consider, and it might be something that we can look at to augment the systems that we have in place. So hydroelectric. Again, I'm not talking about the Hoover dams. These cause a lot of damage to the environment. They can be used for flood control, but there's a lot of downsides to them. Here in Alaska, they're not popular because of fish. As a matter of fact, the Eklutna Dam is being brought down to restore the salmon population, or in the hope of the salmon population. What I'm talking about, something I found a while back, is what's called, from a company called Turbulent Hydro. And this is a fascinating project, and I've put the link with the reference, and I really suggest people go and look more into it. These are relatively small earthwork projects. We're not talking about stopping rivers and moving rivers. The parts are almost totally prefabbed, and assembled on site with very little disruption. They are a low pressure system. The water comes in from the top. It goes through a low speed turbine down below, and it's very fish friendly. It's a low, the fish aren't exposed to fast moving turbines. They're not exposed to high pressure water changes. And one turbine of actually a very low head pressure, that is the distance from the top to the bottom, can produce 24/7 power for up to 60 homes. This might be really suitable for a small village. Down below you can see where they've assembled a couple of them along a string. The other advantage, unlike hydroelectric, where the power is generated has to go through long transmission lines, which again add to the cost and the problems, this can be something set up right next to a community, reducing the loss and reducing the added cost. Then let's talk about biomass. And really there's two kinds of biomass. There's the biomass of just burning. You burning wood in your house to heat is considered biomass. I really want to talk about something called wood gas. This here is actually from Juneau. It is a biomass boiler. It's a pellet stove basically for a boiler system. Um, it is considered carbon neutral. There is some concerns about if the combustion is not proper, you can put soot and tar into the environment. But for the most part, in areas where you do have access to, it doesn't necessarily need to be wood, although a lot of these are made from just waste wood chips from other processes. But it really can be used on any biomaterial. What I'm talking about for this, and what shows a lot of interest, is wood gas, also referred to as town gas. And that's because historically in London, the first street lights, where you would have the guy going around and lighting all the street lights, was um, using town gas. And town gas was coal that was burned in a low oxygen environment. And the resulting off gas was still flammable. And this was a lot cleaner than burning coal as we burn now for power. And the gas would be pumped to all the different streetlights, and then they would be lit. In World War II, there was about 850,000 cars, most of them actually in Sweden and in Europe, where there wasn't a lot of auto fuel, where they were actually burning wood gas for their car. So you would have cars with big, looks like wood stoves on the back of the vehicles. And again, burning this biomass wood in a low oxygen environment um, produces this flammable gas, which can be pumped through an engine with some modifications, but not a whole lot. It didn't put out as much energy. It wasn't as energy dense as, say, gasoline or diesel, but still, you had cars running on wood. And there are biogenerators that work the same way. Actually, you can Department of Homeland Security, there's an old pamphlet you can get that has directions to make your own wood gas generator. And you can take that and plumb that into an electrical generator and power. And there are areas that are actually, they call them cogen plants, that are actually running some large power generation burning biomaterial with this wood gas. So, wind and solar. Not a fan of it, as I said. The wind doesn't always blow, and here in Alaska, especially if you go up north, you're talking about half the year, you're not going to have solar. Um, but up in Fairbanks, you have Golden Valley Electric. They do have, and they've been working towards obtaining more and more power from alternate sources. Um, this plant right here, the Golden Valley Electric, produces about 500 kilowatt hours of power. That's roughly about 10% of the demand. Um, the disadvantage with wind and solar is that power generator has to be used. It can't be stored. Now, they do have a battery storage system, which they use more for the switching, because they do have to go between wind and solar and burning natural gas and other things, and they're switching a lot. So to prevent outages, they do have a battery storage system. But at max capacity, their battery storage can store, I think it was like 25%. So basically enough to power 25% of their grid for, I think, like 15 minutes. So, and it was a very big and expensive system. So realistically, we really can't look at being able to store this power. So we have to use it as it's being used, and then make the switches when it's not available. And of course, we have Fire Island, which all of us here in Anchorage and in the Valley see as we drive on the highway. Fire Island has there are 11 turbines. Um, Excuse me, that's not going to go over well on the recording. There are 11 turbines. From the data I found, they produce, when they are producing power, again, when they're not, they're producing zero, they produce about 17.6 megawatts, which for the municipality of Anchorage is a little over 4%, about 4.3% of the power needs for Anchorage comes from the wind farm when it's producing. And if all the turbines are functioning, all of them are at max capacity. We're talking about 4.3%. And the next time you fly into Anchorage or fly out or you drive by and look and see how many are turning or if they're turning. So again, is it it's a lot of money and a lot of resources, and the return, I'm not seeing the advantage to the return. So one of the things on the rubric, of course, is we want to talk about questions, pose a question. And so other than the data I've spout, what I'd really like to get in and start a conversation over is, number one is, what if they're wrong? It is a um, element of a strong philosophical argument when you can consider the other position and consider the consequences of your position being wrong. How will this affect society if I take us down this path and I'm wrong? This is something that I don't hear from the other side, and I would really like to hear opinions and thoughts from the class. What if they're wrong? What if we go down this path? What if they pose, and you can even take it from my side, what if I'm wrong? What is if my position is wrong? What are the consequences? Um, what if climate change is a natural process? What if we have very little effect, which a lot of the data shows we actually don't have a lot of effect on the temperature change. One of the things that we're looking at many of the things we're looking at to curb climate change are very expensive. They're very resource intense, which if you're a first world country, okay. In some of our work, we talked about, um, you know, other countries. Actually, not in this work, it was in another class. Um, we talked about poor countries like, say, Africa, where they're still cooking and heating inside of huts with wood-burning stoves and being exposed to carbon monoxides and soot and things like that. As these countries develop and they're able to afford things like, say, natural gas, which, yes, it's a fossil fuel, but it's extremely clean compared to others. Um, this actually improves the quality of their life. It reduces their health problems. They have access now to power generation, to clean cooking. Now, is it not arrogant for us to say nobody can use fossil fuels anymore, and to take that opportunity away from them, to take that opportunity to bring them up, to raise their socioeconomic status? One of the things to consider is the United States has actually reduced its global emissions faster than any other country. We did so because we found all of this natural gas under Texas and the Dakotas. And natural gas is a much cleaner gas to burn. So more and more, in fact, in Anchorage, the vast majority of our power comes from natural gas, which is far cleaner. So are we being arrogant? And do we have the right to impose our views and our opinions on other countries, to take away their chance? So I do want to bring up the works cited. This, of course, was in MLA format. Um, uh, the both papers are long reads. I found them interesting. Um, the last entry is for the turbulent. That's their website, and they discuss these hydrogenerate plants, which again I found extremely interesting. And of course, as I tell my daughters, you're never too young to science. So I always have to give them props for being my motivation and keep me going when I don't want to. So I want to thank you for your time and your consideration, and have a wonderful day.